Objective 2, Part 2. So anytime an object is launched into the air, it follows a parabolic path. What goes up must come down, right? So the key features of our graphs all have to have those meanings, or they'll all have those meanings in context, and you'll talk about those. So you're going to get questions, and they're going to ask you, well, what's the maximum height? How long does it take to get there? When does it hit the ground? So I've created this little summary for you to know what they're asking and what you're going to find. So if they ask you, how long does it take to reach the maximum height? Then you know you're talking about the axis of symmetry, because we're talking about an x value of time and a y value of height. So the x value of the vertex would be how long it took to reach that maximum height. So you'll only use the x value. And in these instances, you don't have to put x equals, because now you're talking about a time. So it'll take this many seconds to reach the maximum height. On the other side, we also can talk about the quadratic model in a profit. If you don't charge enough money for an item, then you're not going to maximize your profits. If you charge too much money for an object, then you're not going to maximize your profits because people aren't going to buy them. So if an object is cheap, a lot of people might buy it, but you might not make quite as much money as if you charge the best price to maximize profits. So that's where these quadratics come into real life, because that's the question you always ask. When am I ever going to use this? This is how. So your vertex will tell you what the maximum height is. So, and it's not the whole vertex, but specifically the y value of your vertex. Tells you what that maximum height is or what that maximum profit is. The y-intercept is the starting height or the starting cost. So when I say starting cost, I mean, if you're starting a lemonade stand, you're going to have to buy things, right? So usually the y-intercept for a profit model will be negative. Whereas when you're dealing with an object, it can't have a negative height. So your height will go from 0 to some other positive number. The x-intercepts will be how long does it take the object to hit the ground, because at a y value of 0, that means the height is 0, so it's on the ground. Or when does the company break even? So that is the first x-intercept, is when they break even. They no longer owe money, they are just making no money. Or what price yields no profits? That means they're charging way too much money, so people aren't buying the object. And then you could also find a specific point on the graph, and that would be like, they might ask, what is the height of the object after t seconds? Or how long does it take to reach a height of h? If you're asking about what is the height at the t seconds, that means you're doing t equals. So you're plugging in for t. If they're saying how long does it take to reach the height, that means you're looking for t. So you have h equals. So you're replacing the y or the h of t with that number. So let's do some examples. Looking at example 1, it says a football player has kicked a football from the ground. The x-axis represents the time, while the y-axis represents the height of the football. Label the parts of the graph with the terms below. So these are drag and drop on your screen, not on mine. Your maximum height is obviously the highest height. So this would be the max height. The starting height is where you kicked the ball from. So that would be over here at the y-intercept. And time to hit the ground would be the x-intercept. Example 2 says, a rocket is launched from the top of a 64-foot tall building with a starting velocity of 96 feet per second. The height of the rocket over time is shown in this graph. So I've kind of created this here graph for you. I gave you the points all here. So we have a starting height of 64. We go up. After a second, we're at 144 feet. We reach a maximum height at 3208. Then we start coming back down. After 6 seconds, we're at 64 feet. And then we hit the ground. So we're going to answer these questions. What is the starting height of the rocket? So we see the rocket started, and I'm going to color code all of this. Rocket started at 64 feet. We see it there in our graph, and we also see it in our problem. What is the maximum height of the rocket? So remember, height is a y, so we want the 208 as the maximum height of our rocket. How long does it take to reach the maximum height? That is a time, so we want an x value. So that would be 3 seconds. When does the rocket reach the ground? So the height of the ground would be 0. So that is our x-intercept. That is positive. So that's about 6.6 seconds. How long does it take to reach a height of 144 feet? So we're at 144 feet after 1 second. So it's a how long, so that's a time. So that would be 1. What is the height of the rocket after 6 seconds? So we see after 6 seconds, that's right here. We want the height, so it's 64 feet. That question also could have said, how long does it take the rocket to reach its original height? And that would be 6 seconds as well. Remember, if you're looking for a time, how long, when, how long, that is an x value. If you're looking for what is, that is a height, so you're looking at your y. Time is x, height is y. Looking at number 3, you should try and do this one on your own. So answer these questions based on the graph for number 3. Here are the answers for example 3. If we want to maximize our profit, the cost of our toy should be $20.50. Remember, toy cost was your x value. It's the price per toy. So we look at our maximum point. That'll tell us the cost per toy. What is the minimum price a toy should cost to make any kind of profit? At $3.50, that's our break-even point. We no longer owe money because we're not in the negatives anymore, but we're not quite making a profit. So it would depend. I would just say anything over $3.50 because you could charge $3.51 and make a profit. But that's kind of slicing things. So I would just say anything over $3.50. If the company wants to make a profit of $397,500, how much should they charge for the toys? So remember that our profit was in thousands of dollars. So this point here is really $578,000. So $397,500 would be 397.5 on our graph. So we should charge $30 per toy. You always want to make sure you pay attention to the units of your y and your x to make sure that you're answering questions correctly. Now go to Canvas and complete the practice with key features of a quadratic graph.